Artificial intelligence doctor. User question. What are the underlying biological mechanisms contributing to extreme fatigue in elderly individuals, and how do age-related changes in mitochondrial function play a role? GP-1 answer. Introduction. Extreme fatigue, often referred to as chronic fatigue, is a common complaint among elderly individuals. It significantly impacts their quality of life, reducing mobility, independence, and overall well-being. Understanding the biological mechanisms behind this fatigue is crucial for developing effective interventions. One of the key factors contributing to extreme fatigue in the elderly is age-related changes in mitochondrial function. Underlying biological mechanisms. Mitochondrial dysfunction. Decreased ATP production. Mitochondria are the powerhouses of the cell, responsible for producing adenosine triphosphate, ATP, the primary energy currency. With aging, mitochondrial efficiency declines, leading to reduced ATP production. Lower ATP levels mean cells have less energy to perform their functions, contributing to feelings of fatigue. Oxidative stress. Aging mitochondria produce more reactive oxygen species, ROS, leading to oxidative damage in cells. This damage can impair mitochondrial DNA and proteins, further reducing mitochondrial function and energy production. Mitochondrial DNA mutations. Over time, mutations accumulate in mitochondrial DNA due to exposure to ROS and reduced repair mechanisms. These mutations can impair mitochondrial proteins involved in the electron transport chain, exacerbating energy production deficits. Sarcopenia, muscle loss. Muscle mitochondrial changes. Muscle tissue relies heavily on mitochondria for energy during physical activity. Age-related mitochondrial dysfunction in muscle cells leads to decreased muscle strength and endurance, contributing to fatigue. Reduced muscle mass. Loss of muscle mass decreases the body's overall metabolic rate and energy reserves, making elderly individuals tire more quickly. Chronic inflammation. Inflammaging. Aging is associated with a chronic, low-grade inflammatory state known as inflammaging. Elevated levels of inflammatory cytokines can interfere with mitochondrial function and promote muscle catabolism, leading to fatigue. Immune system activation. Persistent activation of the immune system diverts energy resources and can induce feelings of fatigue. Hormonal changes. Decline in hormone levels. Hormones like testosterone, estrogen, and growth hormone decline with age. These hormones play roles in maintaining muscle mass, metabolism, and mitochondrial function. Thyroid dysfunction. Age-related changes in thyroid function can lead to hypothyroidism, which slows metabolism and reduces energy levels. Nutritional deficiencies. Coenzyme Q10 depletion. CoQ10 is essential for mitochondrial electron transport. Levels decrease with age, impairing mitochondrial function. Vitamin deficiencies. Deficiencies in vitamins B12 and D can affect energy metabolism and muscle function. Role of age-related changes in mitochondrial function. Age-related mitochondrial dysfunction is central to the development of extreme fatigue in the elderly due to several factors. Energy deficit. Reduced efficiency of the electron transport chain leads to decreased ATP production, causing cells and tissues to function suboptimally. Increased apoptosis. Mitochondrial dysfunction can trigger programmed cell death, apoptosis, leading to loss of essential cells, including muscle fibers. Altered metabolism. Impaired mitochondria affect metabolic pathways, leading to accumulation of metabolic byproducts that can cause cellular stress and fatigue. Impaired autophagy. Aging affects the cell's ability to remove damaged mitochondria through autophagy, leading to the accumulation of dysfunctional mitochondria. Conclusion. Extreme fatigue in elderly individuals is a multifactorial issue, but age-related changes in mitochondrial function play a significant role. Mitochondrial dysfunction leads to decreased energy production, increased oxidative stress, and impaired cellular functions, all contributing to feelings of fatigue. Addressing mitochondrial health through lifestyle interventions, proper nutrition, and potentially pharmacological means may help alleviate extreme fatigue in the elderly.